Hello everyone. Today we will discuss about the phenomena of self-inductance. Self-inductance is the phenomena of the production of induced EMF in the same circuit when the current through the same coil changes. So let's write that. When the current through the same coil changes. So for that, a very simple diagram. So what happens is that when the key is pressed, what happens when key is pressed? Key pressed, current increases in the circuit from 0 to maximum value. Current increases means what happens? The magnetic field associated with it changes. Right? This results in change in flux through the same coil. So this results in the production of induced EMF according to Faraday's law. Right? So this is what happens. So now what is the amount of EMF produced? So flux depends on the current, right? So you can say that flux is directly proportional to current, and if we replace this proportionality sign by constant of proportionality, L is called as, where L is the coefficient of self inductance. Coefficient of self inductance, right? And then according to Faraday's law, we know that E is equal to minus d phi by dt. This can be written as minus d by dt of Li. This can be written as L depends on the geometry of the conductor and the material on which it is wound, that we'll discuss later on. So L can be taken outside. This can be written as this. So we have two expressions to define coefficient of self-inductance. This is first expression. This second one I'm writing again here, minus L di by dt. This is the second expression. So we can define self-induction, coefficient of self-inductance. Definition of L. So we will first write the first definition. If I write phi is equal to L when current is 1 ampere, I can define it on the basis of this. So you can say the coefficient of self inductance is equal to the magnetic flux when current flowing through the coil is 1 ampere. Is 1 ampere, right? Second definition can be defined from equation 2. So from 2 we can write E is equal to L when di by dt is 1 ampere per second. So it can be written as coefficient of self inductance is equal to the induced EMF when the rate of flow of current through the same coil is 1 ampere per second, right? So now we can derive the expression for coefficient of self inductance. Derivation of L for an inductor or solenoid. So for this we are drawing a solenoid where this is the current flowing through it. This is the area of cross section, you can say, right? This is the length, and small n is the number of turns per unit length, that is number of turns upon length. So for deriving it, you just have to remember one trick, that flux by flux concept is equal to flux by induction concept, right? So flux by flux concept. So this formula for flux concept we need to recall. The formula is BA cos theta, where B is the external magnetic field and A is the area of cross section through which it passes. So what is the aerial vector direction? This is the aerial vector direction, right? And theta is the angle between aerial vector and magnetic field vector. So in this case aerial vector will be this and magnetic field will also be this. Why so? If you have a coil, so according to this the direction of magnetic field is given by right hand thumb rule. Fingers give the direction of the coil and thumb gives the direction of the magnetic field, or direction of the coil, or you can say the direction of current, right? So this is theta is what? Theta is 0 here. So you can write this as B into A. And how many number of turns are there? N number of turns. So this will be this. For right side, pi is equal to L I. Now what is the formula for magnetic field due to a solenoid? This is mu naught n I, where n is the number of turns per unit length. So we are putting the mu naught n I into A is equal to L I. So from here I can put the value of n. This is n into L, mu naught n into A is equal to L. Why so? Because this I is cancelled. So this becomes mu naught n square A L. So this is the formula for the coefficient of self inductance. From here we can find the factors on which L depends. That is coefficient of self inductance depends. So first is the geometry. Geometry means the length and the area of cross section. Then we have material on which coil is wound. Right. Number of turns also sometimes included in geometry only. So this was all about the self-inductance concept, right? So I hope you understood that. That's all for now. Have a nice day.